y, 11-y, 11-2, algebraic expressions and equations. And now we can combine like terms and solve both of the equations.
And again, it's 11.3 as well, or 11-3 as well, because we're dealing with variables on both sides. Like terms, terms that can be what? Everybody? Combined. Terms include letters or numbers from any sort of equation. And then to distribute means to what, Haley?
Share a term with other terms.
Okay, and this would be an example of distributing. Okay, you are multiplying the 3 through the entire set to get 3a plus 18. That should be something you're pretty comfortable with. Number 2, we're going to go over really quickly, combining like terms. We color-coded, we use shapes. Ultimately, what we're doing is we're looking for terms that are alike that can be combined. If you look at number 4, we underline 5x and 2x in black because together those can combine to make 7x. Negative 3y and negative 8y can combine for a negative 11y, which is the equation we have written down below. We also use, if you're using a pencil, shapes to combine like terms. If you look at number 5, we were dealing with different terms that have exponents. Please remember that if you have an exponent, like a squared, and the variable is x, it can only be combined with another x variable and another exponent that is squared. You can't combine things that are squared with things that are cubed, or things that are squared with things that don't have any exponent or have an exponent of 1. Then ultimately when we write it from largest exponent to smallest exponent would be how I'd like you to write those from this point forward. Terms that are just numbers go where, you guys, in a long equation or a long expression like that?
Yeah.
Numbers go at the very end if you're dealing with variables. Distributing and combining expressions. So number 7, again, we just use the understanding that we have about distributing and then combining like terms. We can go look at number 7 and number 8 if you're confused with that. Brand new learning here, number 4 is foiling. When multiplying binomials, you FOIL. We gave you that acronym, or we gave you that FOIL as an acronym for first, outer, inner, last. We have everything listed here. We talked about what a binomial was, and then we did the example number 10 in a very, very long way, dealing with multiplying the first 2 terms, a times a squared. I showed you that to get a squared, we multiplied a times a, which is this a times this a. The outer side, we have negative 4a, because we multiplied a negative 4 times a. The a is on the outside, the negative 4 is on the outside. The inner term would be 2 times a, the inside term and the inside term. And then the last term, 2 and negative 4, if I slide down here, shows us that we got negative 8. Put those all together, combine your like terms, which the only 2 like terms you have are negative 4 and 2a, and you got yourself your expression by foiling. Another example of FOIL for number 11. And then number 12, multi-step algebraic equations. I think we did 3 of these. All of them involved variables. Or no, I'm sorry, all of them involve fractions. On a problem like number 12, you have a positive 27 and a negative 24. Are those like terms? Should we combine them? Yeah, so in this situation, it makes really good sense to do the easy step first by combining the like terms. What is the part that you struggled with? Somebody explain to me on step number 2 right here. Why did you struggle with this, Madison?
Because I wanted to do it with 2 steps instead of just combining the
And by do what? What are we trying to do? Okay, we're trying to get rid of the fraction, right? In simple forms. We have 2y over 3, and we have 3y over 4 as expressed right here. Let's just get rid of the fraction. The easiest way to get rid of a fraction, especially when you have 2 fractions, not especially, but when you have 2 fractions, find the LCM of your denominators and multiply. So when we multiply both sides by 12, instead of having 2y thirds plus 3y fourths is equal to negative 51, we came up with this equation right here. Do you guys like working with this, or would you rather work with this? The blue or the green? Blue. Blue. Obviously the blue because that looks very, very familiar to you. So go ahead and solve as you know. 13, we gave you the same type of problem, but we have variables on opposite sides of the equal sign. As our friend Tiffany said, get the variables alone now. And you have to work to get the variables alone now. So I'm not going to go through 13, 12, and 14 because you can look at them on your own. They're in your notes. They're also here on the video. Number 14 was just a little bit different in the fact that instead of subtracting 10, we multiply to get rid of the variables first. Jacob, why did we multiply to get rid of the variables instead of subtracting 10 on number 14?
So,
Yeah, but why? Why didn't we subtract 10 first? Because that seems like the easiest thing to do.
because 10 is just adding another popping on the other side.
Well, does 10 have another like term anywhere on either side of the equal sign? No, 10 is all by itself. So if we subtract 10 from both sides, you would just have 10 on the left side of the equation instead of the right side. You're not combining it with anything. Does that make sense? Would it be okay if you go all look up at number 13 and you're dealing with fractions, could you just get rid of the fractions first before doing anything? So on number 13, could I just get rid of the 5 and the 2 in front of the 2m over 5 and the m minus 2 before I subtracted 17? Yes or no?
Yeah.
I could just multiply everything by 10 right off the bat. You could also do that if you choose to. We didn't do that, but you could just say, I just want to get rid of the fraction right away, then I'll deal with the problem. That would be cool as well if that's what you wanted to do. Questions before I stop?